Hello and welcome again to my lesson. Okay, today we're going to do about work, energy, power and efficiency. So in my first part of this video, I'm going to cover about work and what is energy. Okay, so in this whole chapter, we're going to be covering about work done, kinetic energy, gravitational potential energy, power and efficiency. So what is energy, right? Energy is amount of the work that is being done. That means if you are pushing an object, if you are carrying an object, if you are pulling an object, everything of that includes work. Okay, and work is a form of energy, so it is being measured in the units of joule. And work is a scalar quantity, so that would mean that you can be doing work in any direction. It won't be important to know in what direction you are doing your work, as long as you are doing your work. So in work, the most important principle for you to remember is the principle of conservation of energy. The principle says that energy cannot be created or destroyed. It can only be transformed from one form to another. That means that if you have energy that is being supplied to an object, the energy will be absorbed by the object in different form. It does not just fade away, or some part of the energy is absorbed and some part of the energy is released probably to the environment as a different kind of energy, maybe in terms of light. Okay, so there are many examples of energy and situations that we can have that includes energy, such as when you fill up a car with petrol. The petrol it has chemical energy. So the fuel is burned in our car engine to run all the pistons and run the car. So it is transformed into kinetic energy to make the car to move. And then while the car is moving, engine is getting hotter. So there is heat being produced, thermal energy being produced. And at the same time, the engine of the car is making some sound. So there is sound energy that is being given out by the engine, by the car. So here we can see this situation, how energy is transformed from one form to another, from chemical transformed to kinetic, kinetic transformed to thermal and sound. So other examples of energy that we have is energy from the sun. Energy from the sun is in the form of light, not heat. Remember, energy from the sun is in the form of light. The heat that we sense from the sun, the heat that we feel every day, is due to the intensity of the sunlight, not because of the sun is hot. Okay, let us carry on work done. So what is work done? Okay, work done basically in physics, the meaning will be it is the amount of energy that is used to move an object through a certain distance or displacement. That means that if you're pushing a table from one point to another position, you're carrying a box from the ground to the table, or you are carrying something from the table to the ground, all this includes work. All these are called work is being done. Okay, so work done is a form of energy, so it is measured in joule. Okay, the work done by a force applied in moving or displacing the object for a certain distance, displacement or height, it is called work done. So imagine that you have a box and you are applying a 10 Newton force onto the box, and the box is moved for 5 meters. So that would mean that if you apply the concept of work done here, the work is being done by the 10 Newton force to move the box 5 meters to the right. That is the meaning of work done here. So work done has a formula which is given by force times displacement. So in our situation here, so the force applied is 10 Newton and the box is moved for 5 meters. So it should be 10 times 5. 50 joule of energy is being used to move the object from one point to another point. And remember in mind that always when it comes to work done, the force applied must be in the direction of the work being done. in the direction of where the object is moving. So if the object is moving left to right, the force must be applied in the same direction. The resultant force, not necessarily the only force, right? Or if you are picking up a box from the ground to put it on the table, so the direction is vertical. So the force applied must be vertical, which is you are carrying an object up. So you are going against its weight. So that should be the force applied. Okay, and always remember in your mind that the force that is acting is always acting at the center of mass of the object. Okay, because that force causes the object to move. It does not cause the object to turn. So some situation that we have how when we say in physics work is being done. So example would be you're carrying an object up and you're moving forward, right? So you are using energy to carry the object up first and then you are moving forward. You are picking up a barbell by a weightlifter. Okay, a person walking upstairs. This is also considered as a work being done. But which situation is not considered as a work done? You are sitting at home and just typing or just reading on a reading book. That is not considered as a work done by physics in physics. Okay, let's see some example. Imagine that you have the person here. Okay, he wants to raise the box which has a mass of 25 kilogram to a height of 5 meters above the floor, right? So what the person has to do, the person has to do some work against the gravity because he has to pick it up. Gravity is always pulling the object down, so he has to pick it up. So you have to do your work, your force must be against the gravity, right? So the man has to do the work against the weight of the object, right, which is acting downwards, but his work is acting upwards, right? So weight is downwards, this is what we know. So in work done, remember the keyword, the force must be acting in the same direction. So we are not concerned about the force which is acting horizontally. Here we are only concerned about the force which is acting vertically. So vertically we have a force which is weight and one more which will be the force that we apply to raise the object up, right? So the weight of the object will be given by the formula mg. Okay, 25 times 10, it will be 250 Newton, right? So we know that we need to exert a force which is at least 250 Newton to be able to raise the object up. If you are exerting a force which is 280 Newton, of course the object will move up now. But minimum, there must be a 250 Newton force to raise the object up. So that is the minimum force required to at least make the object to start to move up. So hence the work done to raise the object by 5 meters will be given by work done is equal to force times the displacement or how high you are carrying the object. So 250 times 5. So 100 to 1250 joule of energy is required to raise the object up by 5 meters. Let's see another example. In this example, student must know how to resolve the forces. Remember that in resolution of forces, we have learned that forces or vectors can be resolved into two components, which is the x component and the y component. So in this example, that is what the student has to do. So consider the man, he pulls a box of 25 kg for a displacement of 5 meters using a rope, and the rope is being inclined at 30 degrees from the horizontal, right? So the box will be moving horizontally. So when it comes to calculation of work done, we are concerned about the force which is also acting in the horizontal direction, not the vertical direction, all right? Okay, so we assume that the box is not moving up or not moving down. So there is no work being done vertically. So the net force that is acting in the direction of motion it will be given by the x component of the force due to the string minus the friction, which is caused by the 30 Newton friction of the surface. So there is 100 Newton of force that is being applied now, the 100 Newton resultant force. So due to this resultant force, the box will start to move. So this force will cause the object to move, which means that this force will create the work done. So work done will be given by the force times displacement. So 500 joule of energy. Let's see another example about raising an object up, right? Consider in the diagram the object of mass 15 kilogram is picked up on a place where it is 3 meters higher, right? So again, the force applied upwards so that you can raise the object up, okay, against the gravitational force. So the weight of the object is given by again mg, which is 150 Newton, right? So this is the minimum force that you need to apply so that the object can be raised up. So hence, the work done to move or to raise the object up by 3 meters is given by 150 Newton times 3, so 450 joule. Right? So this question can also be related to the topic that we're going to cover later on, which is on gravitational potential energy, which is quite similar. But for now, we will end it here so that you understand the whole concept of work done. I hope these examples and also the explanation help you, and I will see you again in my next lesson. Thank you so much, and see you again.